In the last lesson, we were introduced to lists, which are variables with several pieces of information that can be added to, changed, or removed altogether. Before we begin, make sure that you've completed 5.1 vocabulary quiz posted in Google Classroom. I will take your best score in the gradebook. Here's a helpful message from Mr. Pietrkowski about e-learning. Today's lesson will include activities available in code.org, Unit 5, Lesson 2. What are some similarities and differences between lists and variables? Well, both are used to store information, and both start with a var in JavaScript. The differences are that lists store multiple items, but variables only store one thing at a time. Lists are written with square brackets around them, while variables do not have them. How does a list manage complexity in a program? The answer is that you don't need to know how a list is created in order to use it. All you need is the name of the list. This abstraction allows you to use the list in programming without worrying about specific details of the list, especially when your list can be incredibly long.
One of the benefits of lists is that their length can grow and shrink over the course of a program. But that means it can be useful to find the length of a list at a given point in time. You can get the length for a list like this: numList.length. When your program runs, the computer will replace this with the current length of the list. In this case, the length of the list is 6. A potential point of confusion is that even though the length of the list is 6, the last index is 5. This is because we start the indexing at 0. Because lists change size, a common issue in programming with lists is, what's the index of the last element? We typically find out using the expression list.length minus 1, and you frequently see it used to access the last element of the list like this: numList, and in square brackets, numList.length minus 1. Lists are a very powerful way to store and maintain data in programs. They open the door for us to write programs that use and process lots and lots of information, especially when we don't know ahead of time just how much information needs to be stored. Let's try them out.
Now we'll move into code.org, Unit 5, Lesson 2 for Bubbles 3 and 4. Explore the code and the functionality of each app for the outfit picker and brand namer. Read the program and answer the questions in the Google document posted in Google Classroom.
You can also assign or update a particular index's value. You refer to the slot the same way. Names at index 0 gets the value Sarah would replace the current value at index 0, just like assigning a new value to a variable. Once you have created a list, you can modify it by adding items, removing items, or inserting items. To add an item to a list, you can use the append item function. Let's add Kelly to the end of the list of names like this: append item names Kelly. Notice that append item is a function that accepts two parameters, the list name and the actual value that you want to add. Appending an item always adds the value to the end of the list. To remove an item, you use, wait for it, the remove item function. If we want to remove Josh from the list of names, we'd need to know the index where Josh is stored, so we could do this: remove item names 1. When you remove items, the whole list shrinks and it closes the gap of the item that was removed. Now our list has 4 items, indexed 0 through 3. Because the list shrank, items that come after the removal point are effectively re-indexed. So if we once knew that Kelly was stored at index 4, Kelly is now at index 3. This is not a problem, but something to be mindful of. We can also insert items into the middle of the list with insert item, like this: insert item names to Brooke. The insert item function needs 3 parameters: the name of the list, the index you want the new item to appear at, and the value to insert. Inserting an item grows the size of the list. Similar to remove item, the items in the list that come after the insertion point will be re-indexed. Because indexes are just numbers, you can put anything in between the square brackets that evaluates to a number, like variables or even arithmetic expressions. For example, let's say we're keeping track of temperature readings in a location with a variable called loc. Var loc gets 3. We can change the value in numList at index loc like this. NumList at loc gets 1.
Read Bubble 6 and modify the code. It is important to realize that you can randomize the items in a list. In this programming example, a new variable was created called index that uses a familiar block of code called random number and the list link code that we learned today. This function will update the screen with something from our original list. You can also create on events that trigger a scroll through list items. This is helpful to know for upcoming assignments. The wrap-up activity is a simple one-word fill in the blank answer as a private comment. Also, don't forget to turn in your Google questions.